Sometimes it's not very practical to find the minimum or maximum value of a quadratic function by doing a hand graph. Sometimes you're better off trying to use a graphing calculator or graphing utility on a computer. So that's what this lesson is going to be about, is how to use a graphing program on any computer, iPad, iPhone, Android phone, called Desmos. So you would need to open up your browser, and the program is called Desmos.com, so that's DESMOS.com. And when you type it into your computer or device, you'll see a screen that looks very similar to this. And right there in the middle, it says Graphing Calculator, so you just click on that button. And it takes you to a graphing calculator. And there's two ways to type in an equation to a graphing calculator. If you're using a computer or a Chromebook, you could just type it in directly using the keys on your computer or Chromebook right into the box there in the upper left-hand corner where you should see a blinking cursor right now. If you're using a device like an iPad, like I'm using, or an iPhone or an Android, you can see at the bottom of the screen right now, there's a little miniature keyboard down there with all the numbers. Got the equal sign, plus signs, multiplication signs, everything that you need right there. You could type it into that, and that's what I'm going to have to do since I am recording this video on an iPad. So what we're going to do is we're going to go back to question 47, which says, use a calculator to find the maximum or minimum of each function, round to the nearest hundredth if necessary. It's f of x equals 28x minus 15 minus 18x squared. So I will go to Desmos and I will type that in. And you can see when I type it in that the graph is very, very low. So what I can do on my iPad is I can just touch the iPad and drag it up. If you have a mouse, you can just click on it and hold down the button and drag it up. If you have just a touchpad on a laptop or a Chromebook, you'll need to push down on the touchpad until it clicks and then push up, and then it'll drag it up that way. So that's what the graph looks like. Notice it's a very tall, skinny graph. It'd probably be very difficult to graph like doing a hand graph. And we're trying to figure out what the minimum or the maximum is. So if I just touch, whether you have a mouse or whatever you're using, if I just touch near the top of the graph, and you can see it kind of turn the graph a little bit darker shade of red and put a little point there at the top. And when I touch that point, it tells me what that point is. And you can see that it says it is 0.778, comma, negative 4.111. So which one of those is the minimum or maximum value, and do we have a minimum or maximum? Well, since that point is the highest point of the graph, we have a maximum, and the maximum is based upon the y value. So this graph has a maximum located at negative 4.111, which if we were to round to the nearest hundredth, like the directions say, it would be negative 4.11. So I would answer that by saying that there is a maximum at negative 4.11. Again, I have rounded it to the nearest hundredth, and that is 2 places behind the decimal. Let's try another one that's very similar. It says determine whether each function has a maximum or minimum value and find that value, then state the domain and range of the function. So we're going to go back to Desmos. And I do need to delete my last function, so I can either just use the cursor and backspace all the way. Whoops, that's not the backspace. Or I can just hit the X, which is what I should have done in the first place. And so this time it will be f of x. And remember, instead of f of x, you could just type in a y. So I'm going to use the y here. So y equals negative 5x squared. So negative 5x squared plus 4x minus 8. Plus 4x minus 8. And there you can see it's near the bottom of the screen again. So I'm going to go ahead and scroll it up just a little bit. And just like we did with the last question, I'm going to touch if you got a mouse and an arrow, you would touch that and click on near the vertex of the graph. And there you go. You can see that the vertex is located at 0.4, comma, negative 7.2. So that means, again, we have a maximum value because the vertex is at the top of the graph. And the y value at that point is negative 7.2. So my answer would be that we have a maximum again. And it's at negative 7.2. And then the second part of this question says to state the domain and the range. Well, it's a parabola, so remember that the parabolas, as long as there's not any limitations like a real world limitation, we would say that the domain is going to be all real numbers. And the range is going to be based upon the high point of that graph. And since the highest point of the graph was negative 7.2 and the rest of the graph was below that, we would say the range is going to be y is less than or equal to negative 7.2. The last question is a real-world situation. And being a real-world situation, sometimes that affects the domain and the range. It says baseball. The height h of a baseball in feet after it's thrown straight up t seconds after it's released is given by the function h of t equals negative 16t squared plus 30t plus 5. We're going to do part A, which is the domain and range of the situation, and then part B is going to be part of your assignment. So I've already graphed the situation on Desmos. And again, we're trying to find the domain and range, and we're very used to saying that the domain has to be all real numbers and that the range is going to be based upon the vertex. But this is a real-world situation because what does the domain represent? The domain is time in this case. It's the t value because normally we've got x's where you've got the t's are here. But t is time, that's going to be the domain. And it can't be all real numbers. And the reason it can't be all real numbers is because we know time cannot be negative. And since time can't be negative, we can't say all real numbers because that includes negative numbers. So what we have in this situation is that we know it has to start at 0 for the domain. It can't be any less than 0. So the time's got to be greater than 0. And then what's the maximum time in this situation? So remember what's going on with this ball that's been thrown up in the air. The ball's been thrown straight up in the air, reaches its highest point, and then it comes down and hits the ground. Once it hits the ground, the situation is ended. So what is the time at the point that it hits the ground, which is represented by the x-axis? Well, it's right here. It's that 2.029. So that is going to be the high end of my domain, 2.029. So that's the domain. So then what's the range? Well, again, the range is based upon the y value, and in this situation we want to find how low is it and then how high is it. Again, normally when we look at the y value of the vertex, we say it's going to be that y value and everything less than that. So normally we would say y is less than whatever that y value is. But in this case, we can't just say it's less than that, because if we say it's less than that, we're taking into account all the negative numbers, all the negative heights that would have to occur below the ground. And this ball is not going to be so heavy that it's going to drill through the ground. So, just like with the domain, we've got to consider some limitations. So the range in this case is going to be the ball is not going to get any lower than the ground, which is at 0 feet. Less than or equal to, and since we're dealing with height, we'll call it h, less than or equal to, and then how high did the ball get in this situation? And you can see it's already highlighted. It got up to 19.063 according to our graph at Desmos.